Welcome to this session. This session, we are going to discuss about elementary transformations, or what are also called elementary operations on matrices. So any one of the following operations on a matrix is called an elementary operation. Or transformation. So mainly there are three things. One, interchanging any two rows or columns So this transformation is indicated by R sub ij if the ith and jth row are interchanged. So that's the first transformational operation. Number two, so interchanging any two rows or any two columns. Multiplication of the elements of any row Ri or column by a non-zero constant K and is denoted by K times Ri, or for column K times Ci. And then number three, addition of constant multiplication of the elements of any row Rj to the corresponding elements of any other row Rj is denoted by Ri plus K Rj. So those are the three operations. And then once you carry out these three transformations, if a matrix B is obtained from a matrix A, by one or more of the elementary operations, then the matrix B is said to be equivalent to A. The simple this tilde is used for equivalence. So IA we write A is equivalent to B. So those are what we call the row column operations or elementary operations or transformations. So as an example, here's an appetizer. Reduce the following matrix to upper triangular matrix or to upper triangular form, or what we call the echelon form. So the matrix is given by 1, 2, 3, 2, 5, 7, 3, 1, and 2. So let's start by recalling what an upper triangular matrix is. So solution. An upper triangular matrix is any matrix, any square matrix, not just matrix, is any square matrix in which all the elements below the principal diagonal are zeros. So now let's go to the question. So we want to express the matrix A in upper triangular form. So 1, 2, 3, 2, 5, 7, 3, 1, 2. Now, for us to put this one into echelon form, we expect to have this arrangement: 1, 0, 0, 1, this is 1, not. So this, the kind of pattern we need to have. Now we see from the matrix itself that this position is in the correct form, but this should be 0. This must also be 0. So we start by correcting this part here. So we say row 1 to be row 1, row 2 to be row 2, and then plus a scalar that you multiply by row 1 to get the sum of this element to be 0 is -2, and then multiply by row 1, and row 3 to be row 3, plus you need to multiply this one by -3, so that when you add, you get 0. So this will transform that matrix into one, 2, 3. Now 2 plus -2 times 1 is 0. 5 plus -2 times 2. So 5 plus -2 times 2 gives us 1. 7 plus -2 times 3 is 1. And 3 plus -3 times 1 is 0. 1 plus -3 times 2 is -5. And then 2 plus -3 times 3 is -7. So we say A is equivalent to this because we have used row operations to get that. Now, by doing that step, we see this is the correct format, this is the correct form. So this is a problem. So we say row 1 to remain to be row 1, row 2 to remain to be row 2 because it's in the correct form, but row 3 will be row 3 now plus, I need to multiply this one by 5 so that when I add, I get 0 here. So 5 row 2. So which will be, this matrix will be transformed into 1, 2, 3, 0, 1, 1. Now 0, 0. -7 plus 5 times 1 is -2. So we say A is equivalent to this. Now to get the correct or the final answer, we say row 1 to remain to be row 1, row 2 to remain to be row 2, and row 3, so that I ensure this is 1, I multiply by -1/2 this row 3. So the answer will be A is equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 1 A is equivalent to 1, 2, 3, 0, 1, 1, 0, 0, 1. So this is the required solution. Thank you.